This is the second lesson in the straight line, where we're going to find the gradient of a line. You might recognise this from back in National 5, where you have the formula for finding the gradient of a line, the old y2 minus y1. So we'll go over that again, and then we'll go over a few things. So you'll recognise this from the previous lesson, except this time we've got the gradient formula at the bottom. We've got the y2 minus y1 over x2 minus x1 down here. And also remember that the label, the letter that we use for gradient is m. I want to write it over here like you're used to. Make it a wee bit bigger. This is y2 minus y1 over x2 minus x1. And we still use that in higher maths, so make sure you remember that and how to use it. Watch out for double negatives, and it's m. Remember that it doesn't have any units, and quite often we'll leave it as a fraction in higher maths. That's something to watch out for. Not normally a decimal. So the other thing that we have, and this is new for higher, is we have a different formula, and the formula we're going to use in higher for finding the gradient of a line. Sometimes, and people forget this, it's m equals tan theta, where theta is the angle that the line makes with the positive direction of the x-axis. There's the positive direction of the x-axis, and the line will be up, coming up from there, and theta is obviously the angle we measure from the x-axis to the line. Theta is that wee symbol there, and it says in the box where theta is the angle between the line and the positive direction of the x-axis. So I'll just draw in the straight line. Oh, I'll draw in a better straight line than that. And theta is the wee angle in there, the grey arrow, there's theta. Okay, so we can find the gradient by doing tan theta. So two formulas that we have now for finding the gradient. Let's see if we can use some of those. We've got m equals y2 minus y1 over x2 minus x1. And we've also got this new one for higher maths that we have to remember, m equals tan theta. It's not given to you anywhere, you have to remember that one. We can find the gradient of a line using the angle with the positive direction of the x-axis. We can also use it in reverse as well, and you'll see that in a second. Okay, on to the next. The note that we've got here you should remember from National 5 Maths that positive gradients, they move up from left to right. You can see that there, up from left to right, and then obviously negative gradients are kind of the opposite of that. They will slope down from left to right. So that's down from left to right that way. Other things to remember as well, that it says here lines parallel to the x-axis have a gradient of 0. So basically what that means, there's another name for that. The word, in fact, is horizontal. So horizontal lines have a gradient of 0. So that's what to remember. Any horizontal line will have m equals 0. Okay, and one other thing to remember then is that lines parallel to the y-axis, that's, as you see there, straight up and down, they have an undefined gradient. Now you can use the word undefined in a number of different places. Basically, vertical lines have an undefined gradient. Another word for undefined might be an infinite gradient. For the most part, we use the word undefined in higher maths. So remember that. Horizontal lines, vertical lines, and the gradients that go along with them. And also something else to remember is that when two lines have the same gradient, they are said to be parallel. So this might seem like little minor things here, but this will all come into play later when we cover proper equations of lines. in higher maths. So two lines that are parallel have the same gradient. So remember that, as well as horizontal lines of 0 and vertical lines have undefined gradients. Keep an eye out for that later. So let's move on and have a look at this. So this example that we have in our notes is based around the m equals tan theta formula, because you can see you've got a straight line, you've got the angle. We can find the gradient of that line by doing m equals tan theta, subbing in 32, using our calculator. You can see the angle there, 32, and we'll sub it into our calculator, or put it in our calculator rather, and calculate the gradient of that line using m equals tan theta. The reason why this comes from SOHCAHTOA, opposite over adjacent, that's where we get this 32 from. So our gradient is 0.62. Now normally, as I said, you would leave it as a fraction if possible. This one you can't though, it has to be 0.62. It makes more sense to do it as 0.62. Okay, so we'll move on to this next one. Right, so find the angle that the lines joining P and Q makes with the positive direction of the x-axis. So the minute you see these words, positive direction of the x-axis, you've got to remember that you have this m equals tan theta formula to use. The problem we have here as well is that we don't actually have the gradient or the angle, so we're going to have to do things a bit different. We're after the angle this time, so we need to find the gradient first to then find the angle, and we can do that using our other formula and the coordinates. So we'll have to do the inverse tan of the gradient to find the angle. So the way to find the gradient, which we'll do in a second, is to use our other formula, m equals y2 minus y1 over x2 minus x1, and to sub in our values. So 7's gone in, and we're taking away, watch for the double negative, -2, over 1 take away -2. So that's going to give us 9 over 3, which is going to give us 9 divided by 3 is 3. So the gradient is 3. We want the angle with the positive direction. So we can take that 3 and we'll sub it in over here. And we'll find tan to the -1 of 3. And that's going to tell us the angle this time. So you can use it backwards. You're given the gradient, you can find the angle. 71.6. Okay, so that's a different spin. Okay, this one, the angle, find the size of the angle, theta, shown in the diagram below. So we've got to watch out, we're given the gradient this time, so we don't need to do y2 minus y1. But hang on a second, theta is the other angle, it's not the angle along the x-axis this time. So if I draw in a straight line along the bottom there, we can see the angle that we're actually going to have to calculate in order to find theta. So if we think about the angle that we're going to use this time, if we can pop in a wee x in here, that's the angle we're after, and we can then find theta. So we're going to do, it's jumped, so we're going to do m equals tan theta, but this time we're going to have to use it in reverse, remember, we'll have to do, or tan x I suppose this time if we want to find x, and then we'll find theta. So we're going to do the inverse tan, we'll find x, and then we'll need to do 90 take away that angle. So inverse tan, or rather tan x equals 5. We can find x by doing the inverse of 5. Inverse tan of 5, I should say. So here's the working coming. Tan to the -1 of 5. That's going to give us an angle of 78.7 degrees. And then, as I said, we'll need to find the actual theta angle this time. We'll need to do, since it meets the y-axis like that, we'll need to do 90. There's the right angle. 90 take away 78.7, and that's going to give us a theta of 11.3. Okay, so a wee bit different. You had to find the opposite this time, but we still used m equals tan theta, or rather the inverse of tan. That's a different type of question. Here we go. Some questions on finding the gradient. Now, this one is obviously y2 minus y1. If you want to pause and have a go at these, I'll be back with the answers in a moment. Okay, so our gradient for the first one is 3. For b, remember we're using y2 minus y1, blah, 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 it's negative 2. We're doing m is 0 divided by 4, giving you a gradient of, you can do that, that's 0. And for the last one, watch out for this one, something strange going on in your neighbourhood. It's 4 divided by 0. Now, hang on a second, we can't divide by 0, we get an error. So let's think about this. The question at the bottom there, what can you say about the lines RS and FG? Well, RS has a gradient of 0, and if you remember from above when we talked about it, that means it's a horizontal line. So you're going to state that it's a horizontal line because the gradient is 0. And for D, when we've got a gradient that can't be found, 4 divided by 0 can't be found, so we're going to get a vertical line which has, as we said before when we said the notes, it has an undefined gradient, and so it's a vertical line. So watch out for this coming up when you're working on examples. Horizontal gradients 0, and vertical lines have a gradient that is undefined. Okay, shifting on to these questions here. The top one is a spin on the gradient. See if you can have a go, pause the video, and I'll be back in a second to do this question with you. Okay, so if we do this question over here then, because it's a wee bit different, use the gradient formula, because we've got an x rather than a y2, and we've got the gradient given to us, so we can use all that information to calculate that missing value, x minus 1, y2 minus y1 over x2 minus x1 equals 2. Set it equal to 2 because the gradient's 2. Then we can just form a wee equation. 6 take away 2 is 4 equals 2. Multiply both sides by 4 to get that. Then we can add 1 to both sides to get 9. So x is 9. So we used the formula in a different way. Something we didn't do at National 5, but it's now, it can happen higher. So you've got a few questions here to have a go at for question 3, using the same method. Have a go at those, and I'll be back in a wee second. I should pause the video. Okay, here we go. The answers are x equals 4. For B, the answer is, oh sorry, the answer was actually x equals 9. My dodgy handwriting. X equals 7 for B, and for C is x equals 1. Okay, moving on then to question down below. Calculate the size of the angle mixed with the x-axis. So same as the question we did above, find the gradient, or sorry, it's very similar. Find the gradient and then you'll use m equals tan theta. So find the gradient first with y2 minus y1 over x2 minus x1, and then go from m equals tan theta. So the gradient comes out as 2 over 7. That means that our theta comes out as 16 degrees. These questions below, very, very similar. You're doing the same sort of thing. Find the gradient and then tan theta. And the first one's 68.2, second one 21.8, and 15.9 degrees. Okay, we can move down now and have a look at what's coming next. And this time we've got something similar. The line through the slope downwards has a negative gradient. You can see, calculate the size of the angle this line makes with a positive direction. So we have to be careful this time. We have to picture what's going on. And this time we've got a negative gradient, so it's going to be coming down from top left to bottom right. But we're going to go and find the gradient first. So y2 minus y1 over x2 minus x1. That gives us negative 3 over 6, which is the same as negative a half. make sure the negative's out in front of the fraction. Then we're going to go for inverse tan of a half. Remember, we don't want to put the negative in the calculator, we want to find what that is, 26.6. We then need to remember that it was negative a half, so it's a negative gradient. Look at that. So what angle have we got? That 26.6 is actually, it's not the obtuse angle, we could call that x. It's not the angle with the positive, it's that one in there. So we have to go and find the angle with the positive direction of the x-axis. So we'll need to do 180 minus 26.6, and that will give us the angle we're after. So carefully does it with this. Think about what angle you're actually trying to calculate and do 180 minus the one that you're given. For obtuse angles, keep your eye on that. 153.6. One to watch for. Moving down 6. Same as above, so have a go at these, pause it and see how you get on. Okay, the answer is 111.8 for the first one. And for the second one, remember these are obtuse angles, so it should be larger than 90, 122 degrees. And we've got one final couple of questions just to do. Question 7, straightforward, it gives you the angle, it's on a diagram, calculate the gradient by doing m equals tan theta. And the answer is m equals 2. And then same deal down here, calculate the gradients with the angles in the positive direction. So you're going to put m equals tan theta. The first one's 3, the second one is 0.25, and the third one is m equals negative 2.05. Remember, that's an obtuse angle, so it's going to give you a negative gradient. Okay, same thing here, have a go, pop them into m equals tan theta, see how you go on. Okay, the answers are m equals negative 1.8. And this other one, you'll have to find the angle on the opposite side of the line. So you'll need to do 90 take away 64 to get the angle 26 degrees. And then we can use m equals tan theta to find the gradient of 0.49, 0.5. Okay, so that's us at the end. Let us know how you get on. Contact us in Teams or speak to your teacher in class. And we'll see you in the next one.